Welcome to Lesson 3.1. Last time, we analyzed data that showed us how the amounts of different substances changed inside the beginning and middle of McKenna's small intestine and a healthy small intestine as they traveled through the digestive system. So there's an example of one of the graphs we saw in our previous lesson. So stop and think, what were some ideas we had for what might be happening to the food molecules as they traveled through the small intestine of a healthy person? So we're going to plan an investigation that will help us try and figure out what's happening to molecules in the small intestine. So our investigation question, why do molecules in the small intestine seem like they are disappearing? Why might it be difficult for us to do this investigation using a real small intestine? Why is there a limitation there? Answer the question. So as we plan our dialysis tube investigation, it's important to know when scientists or engineers don't have a sample of the materials they want to test, such as a human small intestine, they often use other materials that have similar structures and functions to conduct their tests. We call this a representation of a system. Scientists and engineers have developed a special type of material called dialysis tubing that has very similar properties to those that make up the surface of the small intestine. So we're going to be drawing a dialysis tube system in our lesson packet. So we're on the very front page of lesson 3. If we are going to use this tubing to represent our small intestine, we need to make sure we are all on the same page about not only how we are going to use it, but what each part of our model represents in the human body. First off, we are not actually going to use dialysis tubing. It is a really cool material, but we actually have something that works just like my dialysis tubing and is a really good model of the small intestine, and that is actually a plastic bag. Can't be any plastic bag, but we do have a type of plastic bag that will work very similar to dialysis tubing and will let us model the small intestine. All right, so anytime you see dialysis tubing, think plastic bag. All right, so the materials we have available to us to model the small intestine include plastic bag, which is our dialysis tube, a beaker, water, and food molecules. So we have a plastic bag, a beaker, water, and food molecules. Go ahead and write these on the bottom of your page. Pause the video if you need to. All right, so we have our box here in the middle of your page. We're going to be drawing our model of our lab setup right here in the middle of the page. So if we look at our supply list, we have a beaker. So let's start with drawing the beaker as part of our model. And let's label that beaker. All right, so we have our beaker. And we're obviously going to have our plastic baggie. So that is our plastic bag. And let's label that. Plastic bag. All right. What does the plastic bag represent in our model? What does the plastic bag represent in our model? Yes, this is our small intestine. All right. So the whole plastic bag is our small intestine. Then the sides of the plastic bag, these would equal the walls or the sides of the small intestine. Okay. And what is our plastic bag, which represents our small intestine, going to be in when it's hanging out in this beaker? Well, if we go back to our supply list, our bodies are mostly made of water. So our plastic bag will be in liquid or water. So this is the liquid around the bag. And that's going to represent the body around the small intestine. And then we had one more thing on our supply list, food molecules. So where in our model should I put the food? Does the food go in the plastic bag, which represents the small intestine, or should the food go in the liquid around the bag, around the small intestine? What do you think? Where should our food go? Yes, I agree. Our food should go inside the small intestine. Food molecules. We should expect the food to be inside the small intestine, right? We saw in our previous lessons that as food works its way through our digestive system, we do end up with various food molecules inside the small intestine, right? We saw graphs of that. All right. Anything else we think we should add? No, I think we have a pretty good setup so far. All right, so your next step is actually going to be seeing how to set up this lab investigation and then collecting some data. When you are done, get your initial model on the front page of your packet checked off by Ms. Helms before you proceed to lesson 3.2. You got this.